Hello, everyone. Welcome to join me in this course. Today's topic is the robot motion workflow. In this lesson, we will focus on an overview of the robot motion workflow, creating and configuring a robot system, defining the initial position and posture of the robot, programming robot motion, robot simulation testing, and exporting robot programs. After this lesson, I hope that you will be able to independently create and configure a robot system in RoboGuide, including correctly adding robot models, setting robot properties, and explaining how these settings affect the working performance of the robot. You will also be able to write and debug simple robot motion programs, verify the correctness of the programs through simulation testing, and optimize the programs based on the simulation results to improve the robot's motion efficiency and stability. Develop a profound sense of duty and mission in exploring the unknown, seeking the truth, and scaling the heights of scientific achievement. Reflect on how to integrate scientific thinking and a strong sense of responsibility into personal development and technological innovation. In recent years, China's robot industry has developed vigorously and has become one of the largest robot markets in the world. Under this background, countless researchers and engineers have devoted themselves to the research and application of robot technology, continuously driving the innovation and progress of the industry. While industrial robot technology is advancing rapidly, the industry faces a host of challenges, including technological bottlenecks and fierce market competition. Let's first look at a case. A well-known domestic robot company, facing foreign technological blockades and market pressure, insisted on independent research and development and continuously explored new technologies and methods. After several years of effort, the company successfully developed an industrial robot with independent intellectual property rights, breaking the foreign technological monopoly and achieving remarkable results in the international market. This case vividly illustrates the spirit of venturing into the unknown and seeking the truth, as well as the tenacity and sense of responsibility in overcoming challenges. It also reminds us that every step of technological innovation is grounded in solid basic knowledge and hands-on practice. Let's start by getting a quick overview of the robot motion workflow. This is the foundation for understanding technological innovation and achieving independent research and development. In RoboGuide, the robot motion workflow typically includes the following steps. First, we need to create and configure the robot system, which involves adding robot models, setting robot properties, etc. Then, we need to add components such as workpieces, tools, and fixtures. Next, we can write motion programs for the robot, specifying its movement trajectories and actions. Finally, we can conduct simulation tests to observe the robot's motion performance and make optimization adjustments. Next, we will introduce the detailed steps of the robot motion workflow in RoboGuide. 1. Creating and configuring the robot system. In RoboGuide, we can create a new robot workstation by selecting New Cell, as shown in the figure. The workstation serves as the environment for robot motion, including robot models, tools, fixtures, workpieces, and so on. Based on actual requirements, click the Add button in the robot list on the left side to import the corresponding models and set their positions and properties. These properties will directly affect the robot's motion performance, as shown in the figure. 2. Defining the initial position and posture of the robot. After the robot system is created, we need to define the initial position and posture of the robot. This can be achieved by using the Move tool in RoboGuide. First, select the Move tool, then click on the robot model, and adjust the robot's position and posture by dragging with the mouse or entering coordinate values, as shown in the figure. Ensuring that the robot is in the correct initial position and posture is crucial for subsequent motion programming. Additionally, we need to consider factors such as the size, weight, and shape of the workpiece to ensure that the robot can stably grasp and place the workpiece. 3. Programming robot motion. How can we write programs that are both efficient and safe? This requires us to continuously explore new programming methods and techniques while always maintaining a sense of reverence for safety. This mirrors the researchers in the case study, who remain undeterred by technical hurdles, driven by a relentless spirit of exploration and a steadfast sense of responsibility. After defining the initial position and posture of the robot, we can begin to write the robot's motion program. In RoboGuide, we can use the built-in programming language to write motion programs, as shown in the figure. The motion program needs to specify the robot's movement trajectory and actions, including parameters such as joint movement angles, movement speed, and acceleration. We can write different motion programs based on actual needs to achieve various robot applications. 4. Robot simulation testing. After writing the motion program, we need to conduct simulation tests to verify the robot's movement performance. How can we identify potential issues through simulation testing and optimize them? This calls for a sharp awareness of potential problems and a meticulous scientific approach. By conducting strict testing and evaluation, we can ensure the safety and reliability of the robot. In RoboGuide, we can activate the simulation function and run the written motion program. By observing the robot's movement trajectory and action effects, we can determine whether the motion program is correct and make necessary adjustments and optimizations. Additionally, we can assess the robot's movement performance and stability based on the simulation results. 5. Exporting the robot program. After simulation validation and optimization, we can export the written robot program to the actual robot controller for real-world validation, as shown in the figure. At the same time, we also need to make appropriate modifications and adjustments to the program based on the results of the actual validation to ensure that the robot can operate normally on the production line. In this mini-lecture, we have gained an in-depth understanding of the robot motion workflow in RoboGuide, and realized the significance of each step, from creating a workstation to programming, setting parameters, simulating motion, and optimizing trajectories. Through a specific ideological and political case, we've also come to deeply understand the importance of the sense of responsibility and mission to explore the unknown, pursue the truth, and strive for scientific excellence. I hope that in your future studies and work, you will always maintain a passion for science and a commitment to responsibility, and contribute to the vigorous development of China's robot industry. Thank you for watching. Goodbye.